So, but in operational theory, any conclusion that a researcher may make after a statistical test is not, in that sense, a conclusion about the empirical reality out there, but just a conclusion about the measurement that was used. Something which we do less often, where this often does operate, where this does come in as an aspect, is when we think about latent variable measurements, which is constructing the measurement from different individual items. So, for instance, coming back to the example of the political party, you could measure one item: do you like the party or not, 1 to 10, or you could measure: do you like the party policy X, party policy Y, do you like the candidate, do you like their program, how did you like the campaign, and so on and so forth. And in sum, all those different individual items might give you a better measurement of party sympathy. And that's where we would rely on operational data theories, and we'll see that day after tomorrow a bit, when we try to consider what's the relationship between the observed variables and the latent variable, the one where it all comes together then, the scale, if you want, so the index that we form. So this is a bit for later. I rather come back to the representational theory a bit more. So what do we measure? Usually as social scientists, we measure direct observables, things that are very clear to observe, physical characteristics of people, for instance, and this very much relates to humans. We measure indirect observables by asking people questions about preferences, attitudes, beliefs, and so on and so forth. Which is, there's a translation process going on there in the individual, so it's more of an indirect measure, really. And sometimes we measure constructs, and we do that in different ways. Again, what we do in quantitative measurement is to apply numbers to objects, basically to turn empirical realities into numerical realities. These should be usually in mutually exclusive categories. So if you measure education, for instance, you usually ask what's the highest level of education, and it should be very clear what that could be, and there shouldn't be categories mingling each other. Often the problem when we analyze newspapers, we ask what type of news article is it? Is it a report, a short news piece, an in-depth analysis, current affairs piece, or 24-hour? Sometimes these things are mixed together and not clearly separable, which makes it really annoying to then analyze such a variable or even code such a variable. So ideally they're mutually exclusive categories, and then we assign numbers to these categories. So this would be 4 people in an empirical map. You've got one with a postgraduate education, one with an undergraduate education, one with high school education, one with no education. That's the empirical reality out there. And what we do is that we simply assign numbers to these different categories, which should be mutually exclusive from each other. So the postgrad gets a 1, the next gets a 2, and this gets a 4. And now I can use the numbers for statistical operations. The empirical map, the numerical map. The empirical relative system, the numerical relative system. Just quickly, because it belongs here in a way, these numerical structures or systems or maps could have 2 different qualities. One is a homomorph mapping or homomorph structure, the other is an isomorph structure. The basic difference is that this would be an isomorph structure because here, with 4 individuals, it is easy to translate back and forth. You know, this person is turned into a 1, and a 1 would be easy to turn back into this person. That's an isomorph mapping system. You can reconvert your numbers into the empirical system. Whereas a homomorph mapping would be something like this. This is measuring genders. You've got males and females in here, and some of them are assigned to male, the others are assigned to female, but you cannot directly map individuals or identify individuals anymore based on this. So you know that any of the 3 in here would be a male, and any of the 3 in here would be a female, but you don't know which. You don't have exclusive categories. To make it clearer, maybe even, again, this is your empirical structure. This is what is out there for persons. They have different income levels. If you do sorry, this is the wrong way around. If you do an isomorph mapping of their income, you see there's 4 different incomes here, and you can translate back and forth between the incomes. You know that this income is attached to all persons and so forth. In a homomorph mapping, sorry, I'll correct it later, you would just map into low and high income categories, and then you would have a hard time translating that. This is, however, what we most often do in the social sciences. We're most often not interested in keeping the very precise attributes of objects, but we're more interested in aggregating into bigger groups in our measurement, which also makes it easier to analyze the data. That's as much as data theory as I want to do, really. But again, you know, there's a theory behind what we do when we assign numbers to objects, and it could be worthwhile considering it. Measurement levels. You know, basic, very basic stuff. You're smiling. Very basic stuff, but important that we all saw it quickly for the rest of the course, really. So there's different levels in which we could measure data, in which we could produce data. Nominal, ordinal, interval, and ratio are the common ones. Very briefly, measurement is about numerical annotation of differences between objects. Nominal measures would measures that, let's put it very simply, where the order in which you assign those numbers doesn't matter, essentially. So the classic example for a nominal variable would be gender. And it doesn't matter whether the 1 is a male and the 2 is a female, or whether the 1 is a female and the 2 is a male. There's no meaning in that, right? Or when I do a content analysis, I'm classifying my newspapers. And it doesn't matter whether and I'm not good in Indian media system, whether the Indian Times, which I think exists, right, is a 1 or a 2 or a 3, and whether other newspapers are something else. That doesn't matter. Right? It's just important that numbers identify certain objects, and that different numbers identify different objects. These measures, some of them are dichotomous. Again, gender is a classic dichotomous variable. There's exactly 2 categories, male and female, although we'll get into the measurement of gender in 3 days from now, because there's a lot that could be said about our still very classic way measuring gender in the social sciences. And there's polytomous items, measurements, which would look at more than 2 categories, basically. That's, I think, should be fairly easy. All of you, in ordinal scales, there's a logic rank order of the values that you assign, from low to high, for instance. I very much agree, I agree a little, I don't agree, I very much don't agree. I don't agree a little, I disagree a little, I very much don't. Still, it doesn't say anything about the distances between these numbers. Like, it's not that in any mathematical way not agreeing is only half of not at all agreeing, for instance. But the logic in which this is measured is is at least in a certain order. We can look at some examples in a second. And then metric scales. In metric scales, the distance between the numbers is actually meaningful. In an interval scale would have no natural zero, and a ratio scale would have natural zero. Correct me if I'm wrong. Some examples. So, you see the basic differences in these four characteristics. Is there a natural zero in there? Is 0 point in there? Are the intervals meaningful or not meaningful? Is there a ranking which is meaningful in the values that the data that we collect? And does it identify differences between objects? That's what all data should do that we measure. So yes, the identification is always given. And then you move down. So merge status, for instance, could be a nominal variable. It's not, married is not better than unmarried, and it doesn't matter in which order you measure. If you have different opinions about that, it's the case. Life satisfaction would be maybe an ordinal variable to be measured. Classic example that many people use: temperature in Celsius as an interval variable, because the zero is not the natural 0 point. And then length, for instance, is a ratio variable. Again, sex, gender, nominal, male, female, at least in the classic sense. Religiosity, how important is religion to you? Ordinal, not very important, fairly important, very important, most important. Most important is not twice as much as fairly important in a mathematical sense. IQ as a interval measure, and here income, because there could be zero income actually, and zero is naturally that it can't be less than zero income, wouldn't be a rich man. Right? We'll come back to these when we talk about questions and surveys, so when we talk about variables and code books. I just want you to have seen these. And again, there's multiple item indices. Sometimes we use different questions, different indices to put them together then to come to a better measurement of them. So individual items about something. We could actually ask the 3 questions about income, and if they relate very well, could put them together into a latent variable that maybe would be the best measure of income. And so they are combined different measures into overall sums, overall means, with factor loadings. We will do a bit more of that later on. This is nice when it comes to complex and multidimensional constructs that we are seeking to measure. And this is very nice from a mathematical statistical point of view, because it uses measurement error. Everything that we measure in the survey, in the content analysis, has error in there. We will never have perfect measures. And error comes from different sources, but there's always going to be error in measurement. The more items you have to measure one construct, the more you can reduce this measurement error in your measures actually. That's the reason why psychologists like to measure psychological constructs with 40 items, 60 item batteries, because the argument is that the reduction of measurement error is so big that the data are more useful. This I wanted to translate at Haven't. What's the relationship between modernization and the meaning of churches, or the meaning of church, or the importance of churches in society? Modernization could be the percentage of employed women. That could be the number of inhabitants in the country. It could be people employed in service sectors, for instance, and so on and so forth. So several items measuring the content of modernization. Importance of churches, its percentage of people paying church taxes, percentage of people going to the service, if they go to the service, if they participate in the. This is the wrong audience to ask questions about Christian traditions and so on. Anyway, so there's again multiple things that we can measure here that would say something about the importance. So multiple indices, multiple measurements important. Much of what we do. When we do measurement, two things are important, and I'll stop talking and have you talk a bit more in about 5 minutes. Reliability and validity. Again, we'll also come back to these from time to time. Are the data that we collect reliable? And are the data that we collect valid? Would repeated measurement consistently come to the same result? And would we measure actually what we intend to measure, what we want to measure? That's the two big issues here. They play interesting. Something that's not working. We want to try this. I'll see. I might have to get it later. This is what we want in an ideal case. We want data that measure what we want to measure, that are valid, that circle around the center of what we're interested in, and that are reliable in the sense of many different points of measurement being very close to the circle, measuring the same thing. Right? What some approaches often have is people test reliability. In content analysis, we get to that. We need to assess internet reliability, for instance. Yeah, very important. We could also end up with this picture. We could have very reliable data, all the different measurements coming to the same conclusions, but we're just off the thing of what we want to measure. Yeah. Interestingly, we could also have very valid data, because if you take the mean value of all these data points, you're right in the center, right? Put all these together, you're here. Very valid across the board, but very unreliable, because very much scattered around. I think reliability easier to assess statistically, so this is often reflected and reported in quantitative research, even if it may be off. Validity is, I would think, less often reflected, at least in the published works that we read. Reliability is basically some sort of repeated measurement. So it's a test-retest situation. If you ask, what we do in panel service, for instance, when we ask the same people twice in a survey, we ask them twice. You couldn't say it's enough to measure their education, religiosity, gender, income once. But we actually like to do that twice, because you can actually compare the quality of the data. Because these are characteristics that shouldn't change in a matter of 4 weeks. And if you've got a survey where we had that lately, 20% changed gender, apparently that's not good, because that's very unlikely to happen. So there was something wrong with the data we figured out, which we maybe would never have figured out if we wouldn't have done the retesting. Alternative form, measuring sample using 2 different comparable measures. Internal reliability consistent of different items within a single measure is something we'll get into when we talk about scale development. Inter-observer reliability is consistency among different observers. That's very important when we come to content analysis, for instance, and we'll talk about that. And many of the things you can get at with standard errors of measurement. So comparing one measure with comparing the different measures to each other and see how much they diverge from each other, how much they differ from each other, how much in statistical sense standard error occurs, and in a very simple manner. Validity again could be a bit more difficult. It's space validity. To what extent does it appear to measure what it should what it should measure? So if you measure in a Western European context nowadays, you measure religiosity and you get super high scores on your questions on religiosity, there must be something wrong. because Western European countries tend to be very secular